Hello everyone, welcome to my YouTube channel. So this is in continuation to our last session where we discussed about analytical functions and different categories of analytical functions. So in this session we will see how these functions works practically. So we will first start with the analytical aggregate function, then we will see analytical value functions, and then we will move to analytical ranking function. So if you have not checked the last video, what I will do, I will paste the video link in the description of this video, and you can check and go through it, and then you can probably start with this session, which is part 2 of analytical functions. So in the first category, which is analytical aggregate functions, we have minimum, maximum, average, sum, count, list, aggregate. So as we already know that analytical function works on the concept of window. So minimum function. So what minimum function will do? Minimum will get the minimum value from that window. Okay. Maximum will get the maximum value from that window. Average will calculate the average, whatever the column name we are passing here. So if we have passed salary column here, so average is going to calculate the average for that particular window for that salary column. Similarly, sum function we have already discussed. This is going to return the sum of all the values in that particular window for that column. Okay. Count is basically count will return the number of rows in that particular window. Okay. List aggregate will concatenate the values within each group. So if we have partition our data, there will be multiple groups which we call as a window. So list aggregate, if we have applied a list aggregate function on that window, it will basically concatenate all the values, whatever the column we have passed here. For that column, this will concatenate all the values. So let's see how these functions will work practically. So in this session also, I'll use the same data set which we used in our previous session. So let me just show you. This is the data which we have in our employee table: employee number, employee name, job, salary, and department number. Now, specific to analytical aggregate function, I will just show you what is our expected output, and then we can actually work on our SQL query. So we will write a SQL query to get the same result. So what I have done, I have just taken a snapshot of the output which we actually want as a part of analytical aggregate functions. So these are the same columns. These are the existing columns which we have in our table: employee number, employee name, job, department number, and salary. Now specific to salary and department number. Now this is also a sorted data on the basis of department number, and I have highlighted on the basis of department number so that we can clearly see that how many buckets are there. So how many windows are there basically. So we have partitioned our data on the basis of department number, and this is for this is my first window, this is my second window, this is my third window, this is my fourth window. Okay. Now the first function which we have which we are applying here is a sum function. So what this sum function is actually doing, this is calculating the total salary in this particular window. So we have three inputs. This is calculating the total sum of salary and associating it with each and every input. Okay, the same thing which we did through aggregate function in our last session. Here we will apply analytical function on this. Okay. Now similarly for maximum, as we already discussed, so maximum is going to give you the maximum value in that window. So this is my one window, and I'm applying my analytical function on this particular window right now. So it will get the maximum value and will associate it with each and every record. Similarly, what is the minimum value for this? 1300. 1300 will come here as a part of minimum analytical function and will be associated with each and every record. Similarly, average, it will calculate the average for this window. How to calculate average? Sum of this divided by total number of values. So sum of this divided by 3. Similarly for department number 20, sum of this divided by 1, 2, 3, 4, 5, 6, 7. Okay, so this is the average 7842, which is coming here, and we are associating it with each and every record of department number 20 and so on. Now the distinct job department wise. So what we are applying here is the distinct count function basically. So count is another aggregate analytical function which we are applying here. So what we are trying to do here, we are trying to count the job we have in that department. So in this department, if you see, we have these jobs: clerk, manager, and president. So employees are working as a clerk, as a manager, as a president in department number 10. So we have a count as 3. And note, this is the distinct count. So if you see in department number 20, so we have, the employees are working in the as the same job basically. So first employee, if you see, is 7369 is working as an analyst, and another employee 7788 is also working as an analyst, and 8104 is also working as an analyst. If we calculate the distinct, it will basically consider these duplicate values as one value. So what is the distinct of these jobs in department number 20 is 4. Similarly, for department number 30, all 3 are distinct. So 3 is coming here and associating with each and every record of department number 30. Similarly, for department number 40, we have the distinct job count as 3, and then we are associating it with each and every record. Okay. Then apart from this, we discussed about the window functions, if you remember. If not, I'll explain you again. So we have 3 categories here: window frame 1, window frame 2, window frame 3. So what we are doing actually in window frame 1, so this is basically the result of, if you see, we are considering all the values. So this is same as this column basically, if you see. So what we discussed it, if you are, if you are assigning, if you are basically mentioning rows unbounded preceding and rows unbounded following. So that means I want to consider all the rows. I don't want to skip any record in that particular window. So this is basically considering all the records, and that's why 8750 is coming here. Similarly, in the second partition, second window, it is considering all the rows, and 54900 is coming as a output here. Okay, so in case it is, if we are using rows unbounded preceding and unbounded following, the result would be same as the sum aggregate function which we are using. Okay, now in the second frame, here basically we are considering one preceding and the current row. Okay, so what it will do while calculating the that value for the current row, it will check for the previous value, and then will basically calculate the sum of both the rows. If there is any previous row, it will not consider the next row because we are not providing following clause. Okay, so we are providing one preceding and current row. So if it is in this row, so we don't have any previous row, so it is coming as 1300. When the cursor will move here, do we have any previous row? Yes, we have. Do we have a current row? Yes. What is the sum of this? Is 3750, and that's why it is coming as 3750. Now when the cursor will move to this, the last record of this particular window, do we have any previous record? Yes, 2450. It will get the sum of previous row and the current row, which is 7450, and that will be associated with this record. Okay, and so on. Similarly, it will apply the same window function to other partitions or other windows. In the last window frame, what we are doing here is we have applied one preceding and one following. So what happens in case of one preceding and one following is, it will consider the previous row plus current row and the next row. So when the cursor will come here, do we have any previous row? No. Do we have any next row? Yes. It will get the sum of this, which is 3750, will be populated here. Now the cursor will move to next record. Do we have any previous row? Yes. Do we have any next row? Yes. It will get the sum of all three, which is 8750, and that will be populated here. Now the second, basically the last record of this window, do we have any previous record? Yes. Do we have any next? No, not in this window, right? So it will calculate the sum of these two records, which is 7450, will be populated in the third record. And similarly, it will calculate this window clause for other partitions also, other windows also. Okay, so now let's try to write a SQL for this. Okay, so I will just quickly move to my SQL developer, and hope you have got the idea what we exactly need here and what is our expected output. So we will try to write a SQL for this now. So I'll be using this data set, and let's apply all the analytical aggregate functions which we discussed. Okay, so let's apply the first function, which was sum, and inside sum we will be passing the salary column. So basically right now we are calculating this data set. So what we are considering, we are considering all the rows. We need not to apply anything, but we are considering all the rows for any particular window. So that means we need to partition our data. That is required here, right? We are not considering all the rows entire data set. Instead we are considering these rows department wise, right? So sum of salary over clause we need to use here, because that will basically tell our database engine that I want to use analytical version of my function called sum. Now as we have seen that it is calculating this value on the basis of department number, so inside over clause I need to pass partition by department number, and this is my sum of salary department wise. I'll give it alias as this one. Okay, now what is next? Next is we are trying to calculate the maximum in that particular window. So in this window, what is the maximum value is 5,000, right? So we will simply use max of salary over partition by, again we are basically calculating this maximum value on the basis of department number, basically for each window. So that's the reason we need to apply partition by here again. Okay, this will become my max salary in department. Similarly for minimum, we just need to change the maximum function to minimum function, nothing else. So instead of max, this will become minimum salary for the same partitions, department partition by department. This will give you the minimum salary for each and every window. Okay, what is next? So we are done with sum of salary, max of salary, min of salary. Now the average of salary. The same query. Now instead of min, we will be calculating average of salary, and this will become my average salary department wise. Now let me just select the data from employee table. So the next is I need to count the distinct jobs in each and every department. So this is our job column, and we need to calculate the distinct job in each and every department. Okay, so I'll make use of count analytical aggregate function here. So basically we need to calculate the count of distinct job. So count of distinct job for each department, it will become my window. So same thing will come in this case also. This will become my distinct job department wise. Okay, now we talked about three scenario of Windows frame. In the first one we are considering the entire window, so that means rows unbounded, unbounded preceding and unbounded following. The second case, so first of all let's try to write this one first. So this will become sum of my salary over partition by department number, order by salary, rows unbounded preceding and unbounded following. I'm writing it at the wrong place with count distinct, so I basically need to specify it here. Okay, and this will become my as window frame 1. Why it's not copied? Just a moment. So this will become as window frame 1. What did I miss? Okay, I missed between keyword. Rows between unbounded preceding and unbounded following. So this will basically calculate, this will basically consider all the records for that particular window. Now the second, what we are considering here, we are considering one preceding, and the current row. So I'll just copy this entire thing and will make the changes in this. This is my win frame 2. So in this I need to consider rows between one preceding and current row. Now my third window is window frame 3. So in that, what we are actually doing, we are actually considering one previous row and one current row and one next row. So basically that is one preceding and one following, which will consider current row as well, right? And that is my win frame 3. So rows between one preceding and one following. So this is basically sum of one previous row and the current row and the next row. Now let's just try to execute this. So we have got the result. Now let's try to see what we have got. So we have employee number, employee name, department number, salary, sum of salary department wise. What we are considering there, we are considering the sum of salary over partition by. For each and every department, we are calculating total sum of salary, which is 8750 for department number 10 and so on. Okay, now the next is maximum of this window. Maximum of my first window is 5000. So that's why it is associating 5000 with each and every record of this particular window. What is the minimum is 1300. That's why it is coming as 1300, and you can check for the rest of the records as well. This is the average of this particular window. Now how many distinct jobs we have? 3. How many distinct jobs we have in department number 20 is 4, and for rest of the department 3 and 3 are distinct job. Now the windowing frames that we calculated. So the first one is same as sum of salary over partition by department number. In this case also we are considering all the values of that particular window. So this particular statement and this one, unbounded preceding and unbounded following, is same. Okay, both the statements are going to give you the same result. Okay, the next one is we are considering one previous row and the current row. So if I go back, one previous row and one current row. So do we have any previous row? No. Do we have a current row? 1300. So in the frame 1, only 1300 will come for the first record. Similarly, for the second record, it will calculate one previous value and current value. Similarly, for the third record, one previous value, which is 3750, not 3750, in the salary column, and will calculate one previous row and the current row. For the last frame, it will calculate one previous row, current row, and the next row. You can check the calculation which we already discussed in our Excel sheet. This is same as what we have in Excel sheet. The same result we have got here. Okay. So in analytical aggregate category, we discussed about these functions. Now let's see how list aggregate is going to work. So what list aggregate will do? So let's consider a scenario that we will use the same table here also. Okay, so what you want to do, basically we have this job column, right? So if you see analyst, so these are the people who are working as an analyst. These are the people who are working as clerk. These are the people who are working as engineer, and these are the people who are working as manager, and similarly other people also. So what I actually want, consider a scenario that I want to see who all are working as an analyst, who all are working as an engineer. So job wise, I want a comma separated list of my employees. Okay, so in such scenario I can use list aggregate. So what list aggregate will do, basically it will combine the result based on this job type and will give this value as comma separated or whatever the separator I am passing. Okay, so what would be my query? I want on the basis of job, right? Now I will apply list aggregate here. Okay, on which column I want to apply? I want to apply on ENAME, right? Now I need to give separator in single quotes. So let's say I'm giving pipe as a separator. Now over clause to tell that I want to use analytical version of list aggregate function, right? Now inside over I can pass order by job. So here not over, so that's a mistake. So we basically in list aggregate, the syntax is we use within group, that I want to apply my list aggregate function on this column employee name. I want to group it, okay, on the basis of job. Okay, I'll give it some alias as employee list. Okay, now let's try to execute this. So what we are getting, because we are grouping the data set, that's why we are getting not a single group function. And as we have used job here, if I'll simply skip this one, what will happen? This will give me all the employees name here. Okay, but I want this to be job wise. So that's the reason if I'm applying any group function, I need to give group by also. Group by job. Now I'll get the result, on the basis of job, and I'll get a list of people who are working in that particular job as a that designation. So who are working as an analyst, this is the list. If you see that it has applied that pipe, whatever you have given as a separator, if I'll give here as a semicolon, it will give the semicolon. So these are the people who are working as an analyst. These are the people who are working as a clerk. These are the people who are working as an engineer. These are the people who are working as manager. These are the people who are working as president. Okay, so this is how my list aggregate function works. So if you have this kind of scenario, you can make use of list aggregate function to display data on a comma separated. So in this way you are actually removing duplicates also. So instead of showing this data in multiple rows, you are actually showing this data in a single row as a comma separated. So this is very helpful when you want to show these kind of values in the user interface. Now let's see one more example. So let me just try to show you the data again. And we'll try to find some other example where we can use this list aggregate function. So let's take an example of department number and address. So if you see so using list aggregate function, if I want to get this comma separated list of address for each department, okay, how I will do that? Okay, so same thing, I'll fetch department number here, then I will apply list aggregate on an address field. I need to give here the separator. In this case, let's say I'm giving pipe separator. Then within group, how I want to order my data, order by department number as, and this will become my address list. Okay, let's try to execute it now. I need to give group by department number also, because this is not a single group function. I have not added that, so that you will get to know, while modifying the SQL, Oracle will itself, or any database will itself show you that what you need to do. This is not a single group function, so you need to give group by clause. DPT number. Now let's try to execute this, and you will get the list of addresses for each department. So we have got distinct department here, and all the addresses where people are staying in department number 10, department number 20, department number 30, department number 40. But if you see, this is the same address. We are also getting the same address multiple times, right? We are not getting the distinct data set. Okay, so what we need to do in that case? So in Oracle 19c or higher version, they have introduced, they have basically enhanced this list aggregate function, where we can directly apply distinct here, and we will get the distinct list of values, distinct list of addresses in this address list. So if you see, this has become invalid because we don't have this functionality in Oracle 11c or 12c version. So I am using 12c version, so we don't have this distinct functionality. But in 19c or later version, we can directly apply distinct here, and we will get the distinct address list. So in this case, what we need to do, basically, we will have to get the distinct list first, and then we'll apply the list aggregate function on top of it. How to get the distinct list first? Select distinct department number, comma, address from my employee table. Then on this address, I can apply my list aggregate function. Let's try to execute this. So now we have got the distinct result, pipe separated. So in this department number 10, all the employees are staying in this particular address. In department number 20, address is same for all the employees. In department number 30, people are staying in two different places. Similarly for department number 40. So how this is working basically? So first we are getting the distinct department number and address from my employee, and then I'm passing this address to my list aggregate function, and then that's how it works in Oracle 11c or 12c versions. In 19c or higher version, you can directly apply distinct keyword here. So what we discussed in this session, so we discussed about the first category, which is analytical aggregate function, and in our next session we will discuss about analytical value functions and analytical ranking function. Okay, that would be our part 3. This is part 2, and part 1 you can probably check in the video description link, and then you can start with this part 2 session which we discussed in this particular session. That is covering the practicals of analytical aggregate function. Okay, so see you in next video, and thanks for watching this video. Do like and share and subscribe to the channel to get more updates.